This is 6.3 trig functions, specifically with angles. Now, one thing I want to remind you about is this little grid here. This lets you know which trig functions are positive in which quadrant. So all of them are positive in the first quadrant. Sine is positive in the second, tangent in the third, and cosine in the fourth. So the first question says find cosine of 135. Well, I also want you to look over to the right. Just want to remind you about the 6 trig functions, and sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. A lot of people memorize that by a word called SOHCAHTOA, and that may help you. And then the other 3 trig functions are literally just the reciprocal of the first 3, the primary ones. All right, so cosine of 135. If I draw a 135 degree angle, notice the reference angle is a 45 degree angle. So at a 45 degree angle, if you remember on the unit circle, a 45 degree angle, at like pi over 4, but in the second quadrant, this is going to be negative square root of 2 over 2 square root of 2 over 2. That's the reference point. And so the cosine of this would just be negative square root of 2 over 2. Now that's one way to look at it. The other way to look at this is because the reference angle is a 45 degree angle, notice the triangle is a 45 degree. And remember the relationship on a 45 is 1 square root of 2. And since this is in the second quadrant, this is actually a negative 1. So that's, to get to this point, that's negative 1 to get to that point. And so we're going to look for the cosine of this. So this was literally, this is 1 square root of 2. And so cosine, if you look at this, this is adjacent over hypotenuse. And so we're going to take the adjacent, negative 1 over the square root of 2, which again is going to lead us to negative square root of 2 over 2. All right, so again, I'm trying to find the cosine of 135 degrees, and so it would be negative square root of 2 over 2. Well, likewise with tangent of 390 degrees. Well, 390, if you notice, if you went 390, so that's literally a 30 degree reference angle. So if you look at a 30, 60, 90 degree triangle, so on a 30, 60, I'm trying to find tangent of this. So tangent, remember, is opposite over adjacent. And remember the relationship on a 30, 60, 90 triangle. So a 30, 60, 90 triangle is 1 square root of 3 and then 2. And then keep in mind we're in the first quadrant, so everything's positive. All things are positive in the first quadrant. So the tangent of this would be opposite over adjacent, so 1 over square root of 3, or just the square root of 3 over 3. And just one side comment, if I'm looking for the exact answer, see, this is the exact answer. This is the exact answer. So if I was looking for a decimal answer, then all I had to do is just plug that into my calculator and get a decimal answer. Make sure you're in degree mode. And the same thing with this next one. I would just have to plug that in degree mode and just get a decimal answer, which, by the way, is a good way to check your answer. So when you plug this into your calculator and you plug 390, tangent of 390 degrees, it should be the exact same answer. So it's a good way to double check your answers. So here, if I ask you the reference angle, we've already talked about reference angle in the last section, but let's talk about it again here as well. So the reference angle is once you travel 5 pi over 3, it's the shortest distance to the x-axis. That's really what it is. So we're talking about a positive angle here. I want to know what the reference angle is. So think of the unit circle, and you go 5 pi over 3. So if we went 5 pi over 3, I went just a little too far. So if we went 5 pi over 3, notice that's 5 pi over 3, but notice what the reference angle is. The reference angle is what's left over to the shortest angle to the x-axis. Okay, and you can easily just do that by just like taking 2 pi minus this, and you can find out, that you're going to get pi over 3. The reference angle is just pi over 3. And then the same thing with 870 degrees. So we know that, if we literally went 870 degrees, so if we went one time around, that's 360. If we went another time around, that's 720. So I'm going to subtract 720 from this. So then we still have 150 degrees more to go. So if we went 150 degrees more, that means I'm stopping right there. So what is my reference angle? Again, it's the shortest distance to the x-axis. So what's left over is 30 degrees. So to evaluate sine of 240, again, I could just plug that into my calculator and get a decimal approximation. But if I'm looking for the exact answer, so what we're going to do is we're going to travel 240 degrees and find the reference angle. And then we're going to basically use SOHCAHTOA to help me figure out what the sine of it is. So if we go 240, so if I'm going 240, that's 180, and then what's left over is a 60 degree more angle. So literally it's 60 degrees more. So the reference angle that I'm looking at, the theta of just the reference angle is really 60 degrees. So literally I'm finding the sine of 60 degrees. So think of a triangle that's 60 degrees. That means this is the right angle, this means the 30 degree angle. And so this, if you label this, that's 1 square root of 3 and then 2. Now remember, it's in the third quadrant, so this is actually -1, this is negative square root of 3, and the hypotenuse is always a positive length. All right, so the sine of this, remember sine is opposite over hypotenuse, so this will be negative square root of 3 over 2. Opposite over hypotenuse, so negative square root of 3 over 2. Okay, let's find cotangent of 495. Well, again, if I draw my, I'm trying to find my reference angle, so if I go 360 degrees, that's one circle, and then I still need to go, just do a little subtraction here, I still need to go 135 degrees more. So if I go 135 more degrees, what's left over, I went 135 more degrees, what's left over is this theta, which is 45 degrees. On a 45 degree triangle, remember the relationship on a 45 degree triangle, 1 of 1 and then square root of 2. Now because it's in the second quadrant, this is actually a -1, this is actually a positive 1, and this is square root of 2. And I'm trying to find cotangent. Well, remember cotangent, tangent is opposite over adjacent, so cotangent would be adjacent over hypotenuse. So in this case, you're going to get -1 over 1, which is still -1. For 16 pi over 3, same thing. I'm going to have my reference angle. I'm going to go 16 pi over 3. So keep in mind, 2 pi is one way around the circle. So if we think of it this way, 2 pi is the same as 6 pi over 3. So if we literally went, 6 pi minus 6 pi over 3, that's going to be 10 pi over 3. Then we're going to minus 6 pi over 3, and that's going to give us 4 pi over 3. So literally we went 2 times around the circle. We subtracted 2 pi, subtracted 2 pi. So we literally went 2 times around the circle, and then we got to go 4/3 of a pi more. So this is literally the theta, the reference angle for this right here. The reference angle is pi over 3. That's really what I'm looking for. And if you remember the relationship of pi over 3, the unit circle, and so this is literally -1/2, negative square root of 3 over 2. And again, we're talking about the sine, so sine is negative square root of 3 over 2. All right, and so let's look at one more. Let's look at secant of negative pi over 4. Well, this one's kind of straight to the point, so it's so negative pi over 4. down to here. So pi over 4, we know this. So we know this is square root of 2 over 2, negative square root of 2 over 2. And secant is 1 over cosine. And cosine is right here, square root of 2 over 2. This goes to 2 over square root of 2, or this 2 square root of 2 over 2, which is just square root of 2. And notice that's finding the secant, and we'll use the unit circle to help us because of the radian mode. All right. And then this one last, I got 2 more problems left. So if tangent of theta equals 2/3 in quadrant 3. So here I already have it drawn out for you. So here they gave me this information. So I went to, and it says quadrant 3. So I drew a reference angle in quadrant 3, and it said tangent is 2/3. So notice I have tangent is opposite over hypotenuse. Now 2 things you got to keep in mind. The tangent is always positive in the 3rd quadrant, but that's because in the 3rd quadrant, when I graph a point here, I have to go over -3 and down -2. They're both negative. The x and the y are both negative, so that's going to end up making a positive. I also notice this. I have to use the Pythagorean theorem to find the hypotenuse, so I get c equals the square root of 13. So I'm trying to find cosine. Okay, if I know tangent is theta is 2/3, I'm trying to find cosine. Well, cosine is adjacent over hypotenuse, and so I'm going to find my exact answer is -3 square root of 13 over 13, and then the decimal approximation is 0.8321. And let's look at our last problem. All right, this is the area of a triangle. So the area is area equals 1/2 AB sine of theta. And a lot of you guys should be used to the area of a triangle without angles. Like normally you might be dealing with the, like if I give you a triangle that has a base times height, you have the base and the height, and you just take 1/2 times 1/2 times base times height to find the area of a triangle, and you could easily do that if we knew the height of the triangle. But we don't know the height of the triangle, so that's why we have this other formula. So if I don't need the height of the formula of the triangle, if I know the degree measurement of the triangle. So here, just follow the formula: 1/2 base times height, sine of 120. Now, again, a lot of you might be tempted just to plug that into the calculator, and that would give you the decimal approximation. But again, if I ask you for the exact answer, you need to find the sine of 120. And again, I came over here, I went 120 degrees, I drew my triangle, what's left over, the reference angle is 60 degrees, and then I did my relationship, and I found that the sine of theta is the square root of 3 over 2. Because remember, sine is opposite over hypotenuse. So the square root of 3 over 2. So the sine of 120 is the square root of 3 over 2, and when you multiply those together, you get this as the exact answer. And then again, this would be the decimal approximation for that. And again, that's the area of that triangle. So how much area is inside of that triangle?